Everyone, this is lecture 10 and this lecture is about quality control of the air in food processing industry. Okay, so what is the goal of air control? To clean the air to the required level for the manufacturing process. Okay, and also use clean air uh, for the process in the food industry where it is required, and also to use sufficient air volumes to eliminate ingress of airborne contamination and maintain process integrity. Okay, so these are the goal that we do or achieve by doing air quality control. Okay, so and it is important because the air of a industry can get contaminated from different sources. Okay, so the air need to be protected from those sources to ensure that the air they remain free from contamination. Okay, or free from unacceptable contamination. Okay, so what are the sources by which the air can get contaminated? So food ingredients and food containers entering the control space, the working personnel, and also the equipments which come into the process area. Okay, from a uncontrolled area. Okay, so these are all the sources. Okay, so these are the sources by which the air of the industry can get contaminated. Okay, so during air quality control, these things need to be, I mean, the contamination from these sources need to be prevented or protected. Okay, well, we see in the first slide that one goal of air control system is to clean the air or treat the air to the required level. Okay, but it doesn't mean that all the air that is used in the industry are cleaned or treated. Okay, in some area of the plant, processed air are required, but there are many places or areas in a plant where the environmental air is used. Okay, so that means the air used on on those areas are not treated. Okay, such as in the stock holding areas, raw food preparation area, the cooking environment or storage facility or the office space, tank containment rooms. In these areas, the environmental air are used. Okay, because okay, theoretically we can treat the air and use in this area. Maybe those will be more safer, but it will add to the cost. Okay, so those will not be cost effective. Okay, so that's why treated airs are or processed air is used only those area where it is required or necessary. Okay, so where the processed air is used or the applications of processed air in the industry. So in this works or in this for these purposes, processed air is used or required, such as contained or high risk food manufacture. Okay, so okay, then in the laminar flow filling machines, which are done in the aseptic room, for the ducted process air, like in many dryers and mixtures or coating system, processed air, I mean ducted process air is used. And for tank blanketing and venting systems, pneumatic conveying, compressed air supplied. So these are some example of the work of a food processing plant where processed air are used. Okay. Uh, this slide it shows some photo where processed air are used is used, such as this uh, top figures of this top part of the slide. It shows the use of processed air for coating purposes. Okay, so and this is a ducted system, and in the food industry, coating, I mean many food are coated, we know that, right? Such as there are candies which are coated with coated also like okay, and many food items that are actually coated with another edible particles. Okay, so in these purposes, I mean in coating purposes, air is used. Okay, and there are different systems like which are like which is like one example is fluidized bait coating system. Okay, in this coating system, food items can be coated with another edible particles. Okay, and there are different machinery systems where air is used to aid in the coating system. So the air used in this kind of purposes should be processed. Okay, should be cleaned enough. Okay, should be cleaned up to the accepted range. Okay, this schematic photo, it shows another use of air. In this case, the air is used to for blanketing. Okay, so what blanketing means? So this is the tank. Okay, so this is the storing tank, so where the say the raw materials or the liquid raw materials is used. Okay, so and time to time the raw materials is pumped out from the tank. Okay, so to aid in the purpose, we cannot keep the this area, I mean where there is no raw materials, so we cannot keep this area blank. Basically there should be air here. Okay, so if air is not present here, it will be almost impossible to pump the these raw materials out. Okay, so in the food industry, okay, so we just cannot use the environmental air here, because you are say you are storing the raw materials here. Okay, so if you use just the environmental air here, so your raw materials can get, or even say it can be a already processed food. Okay, so we cannot use the environmental air, because environmental air may contain different contaminants which can contaminate the stored products. Okay, so that's why the air, I mean this is called the air blanketing. Okay, so there should be air, this is called air blanketing, and this air, I mean the air that is used for the blanketing should be processed. Okay, and this photo show the use of air in pneumatic conveying system. So this is a pneumatic conveying system. So in pneumatic conveying system, I mean materials from the silo storage is conveyed or transferred into the working level materials. Okay, so for example this is the silo, this is the storage. So from here we need to I mean from here the stored materials need to be I mean transferred into the working level machineries time to time. Okay, so in the pneumatic conveying system, air is used to facilitate this transferring. Okay, so the air used for this in pneumatic conveying system also need to be processed. Okay, now we already know that we already know learn about the sources by which the uh, air of a plant can get contaminated. I mean I'm talking about these sources. Okay, so however, uh, in addition to those sources, I mean those are the sources from where the air can get contaminations. Okay, so in addition there are some other factors, okay, which can affect the quality of air. So what are those factors? For example, the rate of air change, I mean in which rate the air of that facility is changing, the direction of the airflow, the presence of different pressure in different area. Okay, so that means differential air pressure. So the room access control, I mean how frequently people goes in and goes out from the room. Okay, and which person can enter the room. Okay, so this kind of things. So that means the room access control, the working personnel, uh, the cleaning procedures. Okay, so these factors affect the uh, quality of the air in a room. Okay, and the air can contain may contain different type of contaminants. Okay, and this different kind of contaminants, they have different sizes. Okay, so such as human hair. Okay, their sizes like around 150 micron. Debris and other particles visible to the naked eye are usually 25 micron, and their size is 25 micron. And 10 micron size is heavy atmospheric dust and fly ash. 5 to 10 micron molds, pollen, large atmospheric dust. 1 to 5 micron bacteria and light atmospheric dust. 0.3 to 1 micron. Tobacco, smoke, bacteria, metallic fumes, etc. So it is necessary to know the size of the contaminants, because we need to process the air. So depending on which quality air we require, we have to set the criteria that, okay, we need that. Say for example, you may need air which is completely free of from bacteria or metallic fumes. Okay, so or you may need a air which may not be that pure. I mean, which may contain tobacco smoke or bacteria, but should not contain the light atmospheric dust or certain bacteria which size more than 1 micron. Okay, or your air can be, I mean, or maybe you need the air which may contain some bacteria but should not contain any molds, pollen, or large atmospheric dust. So it depends on our purpose. I mean, what level of pure water we require. So based on that, we will set the processing, right? So like, say if you want to use the air where presence of bacteria is okay, so in that case you don't need to I mean, think about this size. I mean, you don't need to think about the contaminants which sizes belong to this group, like 1 to 5 micron or less than 1 micron. Okay, so I mean, if I mean, what I wanted to say, I mean, if you want a air where some bacteria can be present but no molds should be present, in that case we just have to care up to this level. I mean, 5 micron. We will prevent or remove every contaminants which size more than 5 micron. Okay, so now if we need a very clean air, I mean, that air cannot contain any bacteria, metallic fumes, or tobacco smoke. In that case, we have to prevent all the contaminants which size is more than 0.3 micron. Okay, so based on that, I mean, how much clean air we need, depending on that, will do the processing. Okay, so in the food industry, the most frequently used method to uh, prevent or remove these contaminants is use of filters. Okay, so there are different type of filters which has different capacity to filter out different sized contaminants. Okay, so again it depends on our purpose. So if we need a very clean air which don't cannot contain anything, then we will use filter which will filter out even these sized contaminants. Okay, so this table shows different I mean, these tables list different standard filters. Okay, and these different standard filters has different capacity, such as for example BSEN 779 standards primary filters. Okay, so these filters are used to filter out particles or contaminators which sizes are more than 5 micron. Okay, and also I mean, these primary filters, they have different grades, like grade 1, grade 2, grade 3, grade 4, and different standard primary filters have different capacity to filter out the contaminants. Say G1, their arrestance is 65%. That means the G1, I mean, grade 1 primary filters, they will prevent 65% of the particles which sizes are more than 5 micron. Okay, and the grade 4 primary filters, they will prevent 95% of the particles which sizes are more than 5 micron. Okay, so there are I mean, this is the primary filters. There are other filters like secondary filters, tertiary, semi HEPA filters. Okay, so the secondary filters, okay, so they are used to prevent or filter out contaminants which sizes more than 1 micron, so like 1 to 4 micron. Okay, so definitely these filter papers will prevent the particles of this size. Okay, definitely they will prevent a particle size of this size. Okay, okay, so and also like the primary filters, the secondary filters have also different grade filters like F5, F6, F7, F8, F9, and these different graded filters, they have different level of efficiency, such as F5 grade of the secondary filters, their efficiency is 40 to 60%. Okay, so that means although the secondary filters are used for this sized particles, but the F5 grade of secondary filters, they will not prevent 100% of this size particles. Okay, so rather their efficiency is 40 to 60%. That means they will prevent 40 to 60% of the particles which sized between 1 to 4 which sized is more than 1 micron. Okay, and the F9 standard, the F9 one, its efficiency is 95% or above. That means it will prevent at least 95% of the particles which sized is more than 1 micron. Okay, okay, so the highest quality or highest efficient filters. Okay, so efficient means these filters can filter out the smallest particle. Okay, so as low as 0.2 micron. I mean, the semi HEPA, especially the HEPA filters or semi HEPA filters, I mean, which are called tertiary filters, they will prevent all the particles which sized is more than 0.2 micron. Okay, so if we want to filter out contaminants as smaller as this, we should use HEPA filters. Okay, so again there are different grades of HEPA filters, like for which are now named, so H10 to H14. Okay, the H10 grade, their efficiency is 85%, but and H14, their efficiency is very high, 99.995%. That means the H14 grade of HEPA filters, they will prevent 99.995% of the contaminants or particles which size is more than 0.2 micron. Okay, so which part filters will use, it depends on which quality of air we require. Okay, well, and different types of filters, they are used in different purposes in the industry. For example, the primary filtration system or the primary filters are used to in the ventilation of warehouse or factories as pre-filters for secondary filters. Okay, so okay, what this means, that the pre-filters, what it means. Okay, so the secondary filters, okay, they are used to prevent 1 to 4 micron particles. I mean, they are used to prevent the particles sized between 1 to 4 micron. Okay, so as they can prevent particle of 1 micron size, why we then need to use the primary filters, because definitely they are going to prevent the 5 micron particles. Okay, so the thing is, if we just use the secondary filter, not the primary filter, what will happen, the primary filter will become covered with the contaminants too often. Okay, too early. Okay, so but if we use the primary filter, they will already filter out and significant amount of contaminants. Okay, so there, so that means the air will be already free from some contaminants, so there will be less chance that our secondary filters will get coagulated. Okay, so otherwise, I mean, our secondary filters will rapidly get coagulated. Okay, rapidly will get covered with the debris, so the filtering system will be the filtering system will be hampered. Okay, so that's why we actually need to use the pre-filters sometimes. Okay, so we just cannot use the tertiary level filter, otherwise we have to very frequently change our filters. Okay, and filters are costly. Okay, so actually that's why in the industry, I mean, it's like if you need tertiary level of cleaning, then you should use all these filters. Okay, so first use the, I mean, first pass your air through the primary filters, then the secondary filters, then the tertiary filters. Okay, so it will be cost effective. because in that case, if you use all types of different types of filters, in that case you don't have to frequently change your filter papers. Okay, especially the HEPA filters are very costly, you know. Okay, and secondary filtration systems, they are used for quality of fish and some processing environments, and the tertiary, that is semi HEPA and HEPA filtration systems, are used for treating the air which is used in the food processing, electronics, hospitals, pharmaceutical manufacturing area, etc. Okay, the air used in the electronics manufacturing industry or the pharmaceutical industry should be very clean. Okay, so the air should be HEPA filtered, then transfer into those areas. Okay, okay, and these are some abbreviation of the filters, like the HEPA. HEPA means high efficiency particulate air, ULPA means ultra low penetration of air, MPPS means most penetrating particle size. Okay, okay, now the filters papers, I mean, we learn about the areas, I mean different areas where different types of filtration systems are used, but in the industry, which are the places, okay, so which are the equipments, so where the filtration unit should be installed. Okay, so these are those places or machineries or areas where the filtration system should be installed, right? Like in the duct inlet, in the mixing box, in the pre-filter system, heating or cooling, fan or motor set, air equalization section, final filter, supplying air duct. So in all these places, we should install the air filtration system or the unit. Okay, so now in the industry, usually there are specific workers, okay, who deal with the air quality. So we can say that the air quality controller. So the persons who will work in this area, I mean who will control, who will maintain the air quality, they should have certain skills. Okay, they should be expert in certain types of works. So what are the skills that are required for a air quality controller? These are some of the skills. Okay, like they should be able to particulate analysis and interpretation for process requirement, airflow pattern and distribution control in the process room, heating, cooling and humidity evaluation, air filtration performance control and integrity checks, mechanical and electrical equipment, basic evaluation. Okay, so it's not necessary that the air controller have to be very expert in mechanical and electrical equipment. Okay, so they might not be mechanical electrical engineer. Okay, but yet they should have the basic idea about the equipments. Okay, and they also should have basic idea about the process control. I mean, okay, they are air quality controller. They will not do the processing. Okay, the food processing or the different processing will be done by different people, but still they should have basic idea about those process. Okay, because if they don't understand the process, they will not realize or understand that what kind of pure air should be required for that process, or whether the process is can the process can act as a source to contaminate the air. Okay, so that's why it's necessary that they, although they will not do the processing, still they should have basic idea about the processing. Okay, and also they should have the capacity to identify problems and assess new and associated work quickly and accurately. Okay, okay, so that's all for lecture 10. Thank you for your patience.